Hey, what's going on? Adam the Tutor here, coming at you with another Laplace Transform video. This time, we're going to be finding the Laplace Transform of a delta function shifted right by t prime, right? Or, you could say this is a, it doesn't really matter. But we'll go with t prime. So, basically, same thing. We're gonna have that our Laplace Transform of the delta function. We're just going to plug into our definition here. So we're going to have the integral from t is equal to 0 to t goes off to infinity of delta t minus t prime e to the minus st dt. Right? Now remember, one of the properties of the delta function is that, well, here, I'll just write it out here, is that delta of t minus t prime is equal to 0 when t is not equal to t prime and is equal to infinity when t is equal to t prime. And additionally, we have that this integral is equal to 1 provided that t prime is contained within, and I think it's not an equality there. I mean, it really doesn't matter, but as long as t prime is in between a and b, right? So again, we're going to use these two facts to evaluate this integral. Well, so if this whole integral right here is 0 unless we have this condition, then, well, t must be equal to t prime. So this t right here has to be equal to t prime. So it's going to come out of the integral, right? Because we have a summation with respect to t. So then this is going to be equal to e to the minus st prime times the integral from t is equal to 0 to t goes to infinity of delta t minus t prime dt. So basically, now the question is, well, is t prime greater than 0 but less than infinity? Well, we're going to assume that t prime is finite, so this one's definitely true, and, well, as long as t prime isn't 0, we're good. So we have both conditions met. So basically, this guy is going to be 1. So then we have that the Laplace transform, and I didn't put a bracket up here. Laplace transform, the delta function of t minus t prime is equal to e to the minus st prime. So that's pretty cool, right? We took the transform of a delta function and we got an exponential, right? Because of the properties that we used, right? So that's basically going to do it for this one. Just a nice short little video. That's kind of the nice thing about integrating a delta function, is that typically when you are integrating a delta function, it is very straightforward, very easy. Because again, the whole purpose of this delta function right here is to be integrated for this reason. So that's going to do it for this one. I hope you enjoyed watching, and I hope you found it useful. If you have any questions or anything like that, drop them in the comment section below. And as always, thank you for watching, and I will see you in the next video.